For the congruency statements, it's all about order matters. So your congruency statement may look different than the one we end up putting on our key for the homework. That doesn't mean that it's wrong. As long as the corresponding letters are in the same spot, then your congruent statement is correct. Does anyone have a congruency statement for the first one that they would be willing to share? Stella?
Triangle CED is congruent with triangle ECT.
I agree. ECT. And what I find easiest when everything's marked and labeled, I just go by the angles. I literally go 1, 2, 3, 1, 2, 3. And I match it up that way. And so if I were to follow that pattern again on the second one, angle 1 with 1 arc, 2 arcs, 3 arcs would be triangle UGH is congruent to triangle UST. And I'm just matching up single arc to single arc. So U to U, double arc to double arc, G to S, and then H to T. So if yours is in a different order, as long as the U's are in the same place, meaning if the U's are second, then they're both there, that G and S are in the same location in H and T, that those have to match as I look through my statement. Same idea on 3. So maybe I say triangle UST congruent to triangle IJT. UST, IJT, matching up corresponding angles. And then that's automatically going to match up corresponding sides. So like US to IJ, single tick, single tick. ST, double tick marks there, marking that length, goes to JT, double tick marks there. It's automatically going to match up your sides by matching up your angles. Last one, maybe you have JLK congruent to triangle UTK. Okay. Are there any questions on how to form that statement? It's all about matching up parts. Okay. And next piece, so this is going to give you some practice with some look-fors. So we're deciding, do we have one of these cases, side, 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 side angle, side, or angle, side angle? But sometimes we're given everything. Other times we have to look for things that add a piece, and we always need 3 pieces to say the triangles are congruent. So for example, on 5, I have the reflexive property here, okay, where I have this middle side on both of them. Reflexive property. And by seeing that, now I know that these triangles are congruent by which postulate? Side, 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 angle, side, or angle, side, angle? Side, side, side. So my response to the question is they're congruent by side, side, side. It wasn't marked all the way initially, but I was able to mark that third side because of the reflexive property. On 6, they don't have reflexive, they don't have vertical angles, and I only have side angle. Is that enough? No, not enough. We're just in homework 27. On 7, do I have enough? Yeah, which one do I have? Looking at just one triangle. Side angle, side. I have 2 sides and an angle. That's side angle, side. I don't have any look-fors there. It's just all given to me. I have a side, angle, and a side. On 8, I have a side and a side, but I do also have something that I can look for there, which is this. What's happening in the middle? Vertical angles here. Vertical angles tell me that these angles are also congruent. And now I know my triangles are congruent by side, angle, side. Side, angle, side, side, angle, side. I'm just looking at one triangle to determine which one it is. On 9, I have it again, I have a reflexive property right here. reflexive property, which tells me that these triangles are congruent by angle, side, angle. On 10, I don't have anything that I look for. They're totally separated, but are they congruent? Do I have one of my cases? Yeah, I have angle, side, angle. Good. Okay, then we get to our proofs. So, and just like I was above, we are gonna be given some stuff and then we're gonna go to some look fors. So first thing I'm given, BC is congruent to DC. Given. As I write givens, it's super important this unit to mark things as I go. So BC to DC. That this length is the same as this length. That way in the end, I'll be able to see which case I have. And then I'm also given that AC is congruent to EC. AC to EC, given. So I've exhausted all of my givens. I need to go to look fors. Do I have a look for here? Yeah, what do I have? I have vertical angles right here. So I know that angle BCA is congruent to angle DCE because they are vertical angles and vertical angles are congruent. Now I'm on my last step, which means it should be this that I'm filling in, and it will be. Triangle BCA is congruent to triangle DCE by which one? Which case do I have here? Cover up one. Side, angle, side. Side, angle, side. And listing where my sides are, well, my sides are in step 1 and step 2. My angle is step 3. So I'm listing in that order. Side, angle, side. Okay. So same idea on the next one. We're gonna write our givens, then go to the look for. So first given is that JK is congruent to LK. Given JK, LK. My second given is that JM is congruent to LM. JM, LM, given. And I'm done with my givens. So I go to look fors, which would be reflexive property here in the middle. So I know that KM is equal to itself, congruent to KM, reflexive. And can I now say the triangles are congruent? Yeah, by side, side, side. So I can say triangle KJM is congruent to triangle KLM by side, 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 which is in 1, 2, and 3. Such a bad glare on that. It's almost like I need a shade. I wonder if I put a shade coming down somehow, like over it, if it would. I don't think it would, right? It's just that light hitting that. That's what makes the glare. It's bad today, though. It's like blurry on there too. Okay. So that, no, we have one more proof. Let's do the last proof. This one's 5 steps. It has bisect. Good one to do. Statements, reasons. So I'm on 13. First statement, angle G is congruent to angle I, given G, I. Then I'm given that FH bisects angle GFI given. Anytime I'm given bisect or midpoint, we follow it up. So GFI is this angle here. If FH is bisecting it, what does that mean is true?
GF is congruent to FI.
No, that would be if it was bisecting a segment, but this is bisecting the angle. So it's going to mean that this angle is the same as this angle. Does that make sense? Because it bisected the angle. So then I would have to write GFH, angle GFH is congruent to angle IFH, because that is the definition of bisect. Okay, that is what bisecting means. So right now I have two pieces, two angles. This one's not going to work, is it? Angle G, like it's not going to give us one of our three cases. GFI, angle G, like we can make it work, but it's going to give us angle side if we use reflexive property, which we can use, but we haven't gotten to yet. I'm just trying to think of why it's even on here. I mean, technically you could say these are the same because triangle equals 180, and then you could get to angle side angle. Look what I had from last year. Let me look. Or maybe I might not have this in here from last year. Because you had a side. Did anyone else do this one? Get stuck at angle side? I wonder if I pulled it from later in the angle side we get to at the end. I may have pulled it from an old work and further out worksheet. Let's see if I can find it. I don't have it in the same order last year. All right, well, let's keep working. We'll work through it. So what's my look for here? What I have reflexive, so I can say that FH is congruent to FH, reflexive. So what I'm saying is this is one that's angle side, which we can use by the end of this unit, but we can't use right now. So because we can't use it, one way that you could have gotten here is you could have said that angle GHF with this angle is congruent to this angle GHF is congruent to IHF. I'm kind of cutting a step in the middle. But we could say a triangle has to equal 180. Okay, so if two angles are the same, then the third angle has to be the same amount. So I'm kind of really shortcutting that step, but that's maybe how you could have gotten to say instead angle side angle. I'm not super worried if you didn't get there, or if you thought you had angle side angle, it wasn't, it was in the wrong order. It was angle side the way it was written. So I probably just pulled it from the wrong worksheet. Okay. So what I'm thinking is, I'm thinking there's lots of people tuned in online today actually, and we do have this checkout quiz to take, but I think what I'd like to do is do the notes first so that then I can let them go. And then you'll have time at the end. You'll have plenty of time at the end to do your quiz, okay? So we're going to, in our notes packet, just kind of briefly take some notes on more proofs. So it'll also kind of help us for our test. Now the proofs that we're going to do are kind of identical to what we have been doing, but it adds a final step in. So it's really just adding one additional step. We won't have them on the quiz today, so don't add this step in today just because we took the notes. And then we'll see if at the end we have time to do more, it'll be okay. I'll do it again with the other group after since they've signed off. Okay, so I'm just one page beyond where we were yesterday. It says notes number 3, CPCTC. We talked a little bit on the first day, which was not a day that you were here, it was a Tuesday, about CPCTC, which is saying, and we did yesterday, we did this, that if I know triangles are congruent, then all of the angles and the sides that match up are also congruent. That's all that CPCTC is. It's saying that all of the corresponding parts, angles and sides, of congruent triangles are also congruent. All of the angles that are congruent, all of the sides that are congruent, okay? So what we can do is kind of add a layer to our proofs. So notice it now doesn't have prove that the triangles are congruent, okay? This is proving that A and E are congruent, which is, of course, are matching angles in my triangles. Okay, to do this, first, I need to state that the triangles are congruent. Then I can state that parts are congruent, which is CPCTC. Corresponding parts of congruent triangles are congruent. So when we are doing these proofs, if we're saying corresponding parts of congruent triangles, then we better first have said that the triangles are congruent, okay? And so really these proofs feel very similar to what we just did. It says given the diagram. So the diagram had marked some things here. I can say that AD is congruent to ED. That's given to us in the diagram. What other part is given in the diagram?
AT is congruent to TE.
Yep, that AT is congruent to TE, given that this side is the same as this side. Now that's all we're directly given in our diagram, but do we have a look for? We have reflexive. So in the middle here, I can say that DT is congruent to itself. Reflexive. See how this doesn't feel any different than the proofs we did yesterday? And now, this is the tricky piece. We're not given this statement because that's not what we're going to prove. So we got to make sure we line things up correctly. So I'm going to go ADT. Triangle ADT then must be congruent to triangle what? ADT. Matching the same sides up, what would we have? ADT would correspond to EDT, yeah? EDT by side, side, side. 1, 2, 3. It's exactly the same as proofs we did the other day. I do this. Oh, that's what it's. A minute. Now that I've said that my triangles are congruent, well, just like the other day when we said, well, if these are congruent, then these sides that match up would be congruent and A would be congruent to E, D to D, T to T. We did that the other day where we listed all the angles, all the sides that match. So if these triangles are congruent, then I can say that angle E is congruent to angle E because they're in the same spot in my congruency statement. And the reason that's true is because corresponding parts of congruent triangles are congruent, or CPCTC. Corresponding parts of congruent triangles are congruent. That's what that stands for. It's kind of fun to say too, CPCTC, and right. Okay. So on the next one, I'm going to change our proof. I'm going to change our prove to, and I'm going to write it this way. Sometimes you see it this way. First, we're going to prove that the triangles are congruent. Is that up there? And then we're going to prove that angle A is congruent to angle D. We're not going to worry about the parallel piece, not this year. Statements, reasons. So this one's funky because it kind of gives it here and then it also marks it here. So that's fine. We just know that this AC and CD is also told over here. Let's start with the first given, which is that C is the midpoint of BE, given. Midpoint bisect, we always follow it up. So if C is the midpoint of BE, then what does that mean is true? What two segments would be congruent? BC and CE. Yep, this segment and this segment. So then BC would be congruent to CE, definition of midpoint. I am also given that AC is congruent to CD. That's given to me. It's already marked on my diagram. So I'm through with my givens. What is a look for that I can see here? Vertical angles. These angles here. So I can say that angle ACB is congruent to angle DCE because they are vertical. And now hopefully I can say the triangles are congruent, can I? I've run out of things to state. Are they congruent by side, 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 angle, side, or angle, side, angle? Which one do I have? Side, angle, side. So side, angle, side. So I have sides in 2 and 3, angle in 4. If they are congruent, then the corresponding parts are congruent, which means A is congruent to D by CPCTC. That A is congruent to D by CPCTC. Okay, now before we are done for today, I think I'll leave we'll see what we have time-wise at the end, but we'll leave the proofs for right now, the rest of them. If you flip this over though, there is a proof bank. So what we're really writing on this blank page are things that we are going to be looking for, okay? So I'll start with the two big ones, which is vertical angles, which means looks something like that when we have vertical angles. And when we have triangles like that, we know that vertical angles are congruent. Congruent angles. Our diagram looks like that. We can write down vertical angles in our proof. Other big one is reflexive property. Many times it looks something like this. Reflexive property. This side in the middle, however you want to write that. If you have just a pencil, circle this side, reflexive property. Okay, something we should be looking for to be able to use in our proof. Okay, now I'm just going to run through some other properties we use quite a bit. So sometimes we use transitive. property, which is, for example, if angle A is congruent to angle B, and angle B is congruent to angle C, A to B, B to C, well then A and C must be congruent. That's transitive property. I'd also take substitution. Midpoint. So I'll write midpoint or bisect and I'll put it together. Needs a follow-up. Midpoint or bisect needs a follow-up. Examples. A, B, C. I just went down the row here. And then I'll go D, E. So label your diagram as I labeled mine. So if I'm given that B is the midpoint of AC, if B is the midpoint of AC, then I know that AB is congruent to BC by definition of midpoint. If I'm given this, then that's true. Or bisect. Give you a chance to write. That was a bad diagram. Bad job. This way. They do not look congruent at all. If, for example, you're given that AC bisects angle BAD, angle BAD, if it's bisected, that means it's cutting it into two equal angles. That angle BAC is congruent to angle DAC by definition of bisect. Midpoint is always in segment that's cut in half. Bisect sometimes is used with angles, sometimes is used with segments. So it doesn't necessarily, it's not necessarily always an angle that's cut in half. It could be a segment, but this one can kind of be used for both. This is always going to be two congruent segments. And one we see sometimes, not as often, is perpendicular, which is really the same as midpoint and bisect in terms of it needs a follow-up. And it actually has two follow statements. So anytime I'm given perpendicular, I actually have two statements that follow it. So I have A, B, C, and I'll call this middle point D. And what maybe we're given is that BD is perpendicular to AC. Okay, perpendicular is that symbol there. BD is perpendicular to AC. What perpendicular means is that they're hitting at a 90-degree angle. So what follows that is first, I would say that angle ADB and angle CDB are right angles. So let me pretend this is a little proof. Because that is the definition of perpendicular. Okay, that's the first thing I would say. Second thing I would say is that they are congruent because they're both right angles. So all right angles are congruent to each other. Okay, so there are two statements that I say to follow up on something that I'm told is perpendicular. It's the homework page. So if we have time at the end, we'll do some more proofs together on CPCTC. I don't know if we will have time, so we'll kind of see where we land. In terms of, watch this, let's see if I can do this. It's so fancy what I was shown the other day. Yeah, there's a horrible glare today, Trinity. I'm not sure why. It's worse than normal. I'll scan in the notes afterwards if you couldn't see anything. I'm gonna share screen. It's not giving me a screen. Do this one. Okay, let's see if I can do this. I was shown this new thing. Oh, this isn't this week. It's fine this week. There we are. Okay. I'm excited to try it. Let's see. It's gonna be magical, just so you know. No, I don't remember which button to press. Hold on, I'm gonna get it. That's not it, that's not right. Video. Okay. I think that's what it was supposed to be. I don't know what's happening now, hold on. Okay, are you ready? Anything, look, that's my laptop right there. I didn't even have to plug it into the, it's an amazing thing, right? I'm glad I tried that. So today, so we haven't done the checkout quiz yet. We went over homework, we did this. If we have time, we'll do this, but I just want to point out that there's homework for next Monday, that is more of these CPCTC proofs, okay? And then when you're not here next week, just kind of try to keep up as much as you can, zoom in if you can, because the goal is to have no work over Thanksgiving break. So for these kids, we'll also still talk about the old homework a little bit. We'll talk about the new CPCTC stuff, and they have a checkout quiz to take. And this is our last, is it the last section? No, there's another section Tuesday. So there's going to be more notes next week, homework that goes along with it. This is the last day of notes. And then what I have planned on Wednesday is again for you to be asynchronous and just be working on the unit review. So that also hopefully means that if you missed either of those last two lessons, you can go back and complete those. And when I see you Thursday, we're going to go over the unit review, and hopefully the blue group will join us for that. And then on Friday, you're lucky because you're here. It's a good one, right? It's a good one. Yeah. Is that everyone will take the test so that you can then leave and go on vacation, we'll have finished the unit, done, set to go, take the week off, okay? So that does mean the blue group will have to zoom in and take it. Okay, so that's just kind of the plan. And since I know you are gone the first half of the week and then you come back and it's gonna be like review test, let's try to stay up on the videos, doing the homework, checking the homework. Like when I post the homework keys, it's not just for fun. It's so you can kind of check and see how you did, especially with some of the proof stuff. Okay, so now I think we might have time to do this warm up at the end. Now I'm gonna give you this checkout quiz. You can use your resources. Again, it's a 100-point formative quiz. And then if we have time, we'll do this. But when you're done, you can start the homework. It's like 4 proofs, homework 28. But they're CPCTC proofs. They're the new ones. Is there any CPCTC proofs on your quiz that we're gonna do right now?
No.
No, that was new. Okay, good. Pretty cool though, huh? Right? I like it. All right, so well, let me pass that out and then I'll have them. I can just disconnect, I think. Stop sharing.